Right, so I was looking at the video I made yesterday and I realized it cut off right at the end, right when I was getting to the final part. So I'm going to finish up with the supernova type 1. And in type 1 supernova, remember we have a white dwarf and we have a red giant star. And if they're close enough together, then when the red giant star expands, which all stars do as they get older when their core starts to change what fuel they're using, it will start to drop material onto the white dwarf. The material spirals in to the white dwarf, lands on the white dwarf. Well, the white dwarf is a very special kind of material. It's called degenerate material. And it's made of carbon and oxygen. Now the key to this, what we call an electron degenerate term, means that the star can only be so big. If it gets so big, then the gravity is so strong that what's holding it up are the electrons get crushed. And so that magic number is 1.4 times the mass of the sun. Remember the M circled out means mass of the sun. So if this white dwarf, which when it's created is usually only about 1 solar mass, but if you throw enough material from the other star onto it, it can get bigger than this amount. Especially if you throw it on fast. So all the material just starts falling onto here quickly, then the white dwarf will collapse. When the white dwarf collapses, all that carbon and oxygen will get heated up so quickly through the whole star that it will blow up the whole thing. It'll become a nuclear bomb the size of the Earth. All the carbon and oxygen will instantly fuse. And when you do that, you create a type 1 supernova. The good thing about type 1 supernovas, or not really good, but the thing that astronomers like about them is because white dwarfs are all about exactly the same size, when they blow up, they're all the same brightness. And we can use that to find the distances to faraway galaxies when we see these supernovas go off. So for astronomers, these are very specific supernovas. We like them a lot. What about the effects on Earth if you have a type 1 versus a type 2? The truth is it's still just as bad. Because when this whole carbon-oxygen Earth-sized object blows up, you also release massive amount of cosmic rays, gamma rays, all those bad things that come flying at the Earth. And so if it was close by, you would have just as big a problem. So it really doesn't change whether it's a type 1 or type 2 supernova. If it happened close to the Earth, it could be bad for life on Earth. So that's the difference. Remember, type 2 supernova is a core collapse from high mass stars. Type 1 is from a binary system in which one of the members is a white dwarf. Okay, that's it for supernovas.